Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, meet me again in chemistry class. And actually today I want to talk about enthalpy. But before we start our lesson today, please raise your hands like this and do our before study. Bismillahirrahmanirrahim. Rabbi zidni ilmah warzuqni fahma. Ya Allah, give me knowledge and good understanding. Amin. Okay, in this video, we are going to focus about how to calculate the enthalpy change of reaction. So watch this video until end, okay? Check this out.
We are going to focus on how to calculate the enthalpy change of reaction. So, consider the combustion reaction of ethanol plus oxygen combustion, and you have a hydrocarbon which usually react with carbon dioxide, and the product of the combustion reaction is always going to be CO2 and water. Now go ahead and pause the video and balance the reaction. Notice that we have two carbon atom on the left side. Whenever you are balance the combustion reaction and balance the carbon atom first, and after that we move on the hydrogen atom and save the oxygen atom for last. So we have 3, 4, 3 for each, and after that we have total 7, right? And now 4 plus 3 is 7, and 7 minus 1 is 6. Okay. Now we can, let's say it's 278 kilojoules per mole, and for CO2 minus 393, and for water is negative 2H6. So we have the change of enthalpy. Substance is this information to calculate the to be changed entire reaction. So in this sum of the enthalpy change of information for the product minus the sum of the enthalpy change of information for the reaction, the product is everything on the right side. That include the 2 carbon dioxide molecules and 3 water molecules. The reactant is everything on the left side. That includes ethanol and the 3 oxygen. So now on this point we need to plug in the heat of information for each substance. So for Cl2 it's negative times 2 because we have a 2 in front plus 3 times, and the water ethanol is negative. And now for any pure element in our natural states, the enthalpy of information is 0. That's right, and going to be 3 times 0. Okay, and then we have a plus 7 negatives and minus. Okay, and you see the calculate is by taking the difference between the sum of the enthalpy of information of the product minus the reactant. Okay, so what exactly is the enthalpy of information of reaction? Yes, enthalpy of information of reaction, the enthalpy of a certain type of reaction, a reaction where a compound, 1 mole of a compound is produced from its elements in our natural state. So let's write the reaction, the enthalpy information for the reaction of carbon dioxide. So we are going to reduce 1 mole of carbon dioxide. You can say can it thanks to the two known elements that make up Cl, to carbon and oxygen exists as a 2 in its natural state is diatomic. So the enthalpy of this reaction is equals to the enthalpy of information for Cl2. Now let's prove it. We'll know that enthalpy of reaction is always equals to the products minus the reactant, that is the sum of the product minus the sum of the reactant. So it's going to be 2, which is product, that is 2 reactant carbon plus oxygen. By the way, this is a gas, and this is a solid. So the enthalpy information for to end say it was negative 393, and the enthalpy for pure element is always 0. Thus the enthalpy of reaction is equals to the entropy of information for carbon dioxide. Why? Because we have only pure element on the left side and information is 0, the only component. So the enthalpy of the reaction will equal the enthalpy of information. So as you can see, the enthalpy of information is the same of the enthalpy of reaction for any substance that is product from this element in a natural state. Now, would you write the reaction that associated with the enthalpy of information for the water and ethanol? So we're going to put water on the right side, and the elements that make up water are hydrogen and oxygen, both of which are diatomic. So we need a 1 in front of water. We can't say anything else to the number of hydrogen atom is balanced, but we have 1 oxygen atom in the right side but 2 on the left. So half is simply half, so we need half in front of oxygen. So now it's balanced. The enthalpy for this reaction is the heat of information of water, which is approximately about negative 286. Now how would you write the reaction for ethanol? Yeah, that's right. You're going to have one ethanol on the right side, and the element make up ethanol or carbon, hydrogen, and oxygen. So we have 6 hydrogen atom on the right side, and 6 divided by 2 is 3, and only 1 oxygen atom. So we need the half, and the enthalpy change of the reaction is equals to the enthalpy information for which is negative. That's right. Let's go ahead and add the other one for carbon dioxide, which we wrote already, and so that's negative 393. Now their question for you, you can see use has law to estimate the enthalpy change for the combustion of ethanol. Yes, that's right. And so we have previously, so what we need to do is we need to adjust these three questions in such way, and we'll get to the equation we have one the bottom. So notice that we have one water molecule on the right side, so we are going to multiply this reaction by 3, and we have two carbon dioxide molecules on the right side, so we are going to multiply this reaction by 2 because we want to the carbon dioxide is one the right and ethanol is one the left side, so therefore we need to reverse the third reaction. So for water we want 3 molecules on the right side, so we need 3 hydrogen molecules here, and this is going to be 3 over 2 oxygen molecule. Now if you multiply the reaction by 3, the enthalpy, you got to multiply the enthalpy by 3, so it was negative 2H6, so it's now negative 2X times 3, which is negative H5H. That's the enthalpy of change of this reaction. Now the takes one was carbon plus oxygen, which turn into carbon dioxide, and because we had 2 carbon molecules on the right side, we need to multiply this reaction when to the enthalpy change was negative 393, but we got the multiply that by 2, and this is going to be a negative 786. Now for the reaction with enthalpy we have to reverse it, so we need a 10 on left side, and on the right side we have the elements that up ethanol, that's carbon hydrogen and oxygen. Okay, you see, and the entropy of information of ethanol is negative 278, but because we have to reverse it to not going to be positive 278, so what we are going to do is we are going to add these 3 reactions. So if we add the notice that hydrogen to cancel, and the left side 3 on the right, so they completely cancel in additional. So everything on the left is focused on the oxygen atom. Actually this is ethanol, and the half of the right side, and we'll cancel the we will have to, because the 0.5 minus 0.5 is 3, so we are going to have 3 oxygen on the left side. On the right side the wood simply fell down, and to be 3 carbon and 3 hydrogen on the right side. So now if we add the reaction 1 2 3, and since we come up the reaction according to Hauss law, the enthalpy change of that reaction can be calculated by adding the reaction, the enthalpy change of individual reaction, that we just get the reaction. So we got the 8 negative 8 plus negative 7 plus 2 7 8, and the same answer, and we had in the example which is negative 1366, and we calculate the enthalpy change of a reaction using product minus reactant, or even use intensive law.
Alhamdulillahirrahmanirrahim. Enough for today. Before we close our study, please raise your hands like this and dua after study. Bismillahirrahmanirrahim. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaihi. Amin ya rabbal alamin. I hope you understand what the explanation today, and if you don't understand, don't be shy. You can ask your subject tutor or you can message me on my Instagram. Okay? Assalamualaikum warahmatullahi wabarakatuh.